We're here today to talk about how we made warbyparker.com really, really, really fast. There's the answer, the delight and difficulty of universal JavaScript with React. So talk's done. Woo! No, really. We're going to talk a bit about the front-end architecture and how we overhauled it to the stack. We're going to talk about how we operationalized it and monitored it and all the stuff around that sort of glorious area. So I'm Dan Morel. I head up TechOps at Warby Parker.
And my name is Michael Branch, and I'm a senior software engineer at Warby Parker.
So we're like DevOps, right?
Yeah.
All right, so we're Warby Parker. Warby Parker, we were basically the first online retailer of glasses back in the day. That was way back in the aughts in 2009 when Warby Parker launched. We're far more than that now. We don't just sell glasses, we sell sunglasses and books and umbrellas and all kinds of awesome stuff that our product team comes up with. And we don't just sell online anymore. We actually have real brick and mortar stores. We've got 20+ beautiful stores around the country. We're launching new stores all the time. I feel like right now we're doing like one new store a week. It's really crazy. And all this shift in our business had a really interesting impact on our stack. So one big trend that I think everybody knows about is just the shift to mobile, especially in commerce. People in e-commerce see more and more people coming in for mobile to buy stuff. There's a very similar trend in brick and mortar retail. I think there's a talk later by somebody from Target called Brick and Mobile, which is kind of one of the fun names of this trend. So people do stuff with your mobile site when they go to your store. So this created a whole new interesting set of problems for us to solve.
So we had a common problem, actually. A lot of people have this situation currently. We had two separate sites. We had a mobile site and we had a desktop site. And there was differences between those sites that weren't ideal. There was sort of visual inconsistencies between the sites. There was also feature inconsistency between the sites. So some features were implemented on mobile that weren't available on desktop, and vice versa.
And it was slow, especially our mobile site. Our desktop site wasn't too bad, but our mobile site, as you'll see in a second here, it wasn't the most pleasant of experience for our customer. This was largely driven by one particular page. We have the product gallery where you have hundreds of images of all our glasses. Like you go select glasses for men, and there's a big gallery page, and it would render and load not in a wonderful way.
So we decided to rebuild our front end, and so I'm going to talk a bit about the architecture of our new front end, and then hand it over to Dan, who will talk more about the performance and monitoring of the front end. So when we decided to rebuild our site, we actually decided to go fully responsive and engineer a single site, which could be a great and consistent experience for our customers. The reasoning behind that is that, more and more traffic is coming from mobile devices. We're heading towards 50% of traffic, at least on warbyparker.com, that's mobile. And going responsive just future-proofs us for the wide variety of devices that there are out there and will be in a couple years. And also, it allows us to kind of focus in on a single site and make it performant, instead of trying to maintain two different sites that essentially have different technologies behind them. So what did our legacy front end look like? There was some good stuff that we were doing, and there was some less cool stuff that we were doing. One thing that I think we were doing well is that we were using API-driven features in a lot of places, using Backbone, not an uncommon thing. And so the team was used to building like very small pieces of functionality with Backbone mapped to API endpoints. And the thing that was not so good was our templating situation. How are we generating markup? We're a Python shop, and behind the scenes we were using Jinja. We had some Jade mixed in there. There's a Python implementation of Jade. And then we were also using handlebars for client-side templating. And there's even React in some dark corners of our site. And then finally, the worst vendor of them all was jQuery DOM manipulation, which was happening on some of our core pages and was very difficult to debug because it happened in unpredictable ways. So what could we do about this mess? I think that we were in a good place because we had this API-driven situation already. And so we had just enough experience with React that we felt really good about it. It solved a lot of performance problems for us when building complicated UIs. And so we decided to go forward with an approach where we used React on the client and on the server. And in order to do that, because React is a JavaScript technology, we needed to introduce Node to our stack. And so basically, a view of our legacy architecture. This is a really simple kind of diagram of it. We have Python applications that are talking to a Postgres DB and Nginx in front. And so my proposal was that we start using React everywhere, and we put in a node layer in front of the Python apps, and basically allow our React components to be rendered on the server so that we can deliver really clean, usable markup to on every request. And then later in the browser, React would take over and handle any DOM transitions from that point forward. So this was my proposal, and we ended up going through with it, which is great, and talk about some of the other things in it here. The timeline. So the project timeline looked roughly like this. So we decided to deliver this change in phases, and the phases are outlined here. We kind of picked the first phase being our customer center, and our customer center is a place where you basically view any orders that are in progress or change your email, things like that. And it was like a portion of our site that had a very different experience between mobile and desktop, so it was a good candidate to test building something responsively. And it also didn't get a huge amount of traffic, so we felt comfortable kind of testing the waters with our new stack just on Customer Center and leaving the rest of the site untouched. So why did we choose to use a fully API-powered front end? Well, I'm a big advocate of it. It's certainly not a requirement if you're using React. It's not any sort of like necessity if you're building a React front end, but it certainly makes things easier. I think it's also a really good approach because you are able to sort of like decouple your core business logic from your views and just really have to think about how you expose the different features that your application implements in a really clean way that can be consumed by any number of like different software. So that's one of the other reasons why API-powered front ends are nice, is that if you need to invest in an API, you get the cross benefit of possibly being able to support a mobile application or maybe third-party integrations. The other reason is that I think it also lets your engineers hone in on their sort of domains of expertise. So our back-end engineers can make a super performant API endpoint, and our front-end engineers can kind of like work more solely on the front end and not worry about back-end stuff quite as much. So all in with React. So we are all in with React, and if you don't know what React is, just a like quick primer is that it's basically an abstraction on the DOM. And what it does in the browser is really lovely, and it lets you build components that render markup, and then as those components change in response to like user behavior, React changes the DOM in a very efficient way that's super high performant in most cases, in most like general use cases. On the server, React just becomes a way to render HTML markup. Super simple, really nice. And we went all in with React to the point where we were not using jQuery or any other DOM manipulation at all. If something needed to change live on the site, it's going to happen within React, and we're going to do it strictly that way. So React also enables something that's really nice, and that's reusable components. Reusable components basically, and I'll talk about how we're using them at Warby Parker, but basically they give design and development a really nice visual language to talk about how you're building user interfaces. And the fact that they're reusable is a really lovely thing. They kind of, at least for us, the way we use components is they sort of encapsulate sort of like a functionality, style and look and feel, and then oftentimes also analytics. And so we quickly figured out when we started this project that we're going to build all these reusable components because we want to make sure that our user interfaces are consistent. We want one button component, and everyone uses that one button component and adds functionality to it over time. And we quickly realized that we needed sort of like a home base for all these components to develop them, to test them. And so what we came up with is a thing called Component Lab, which basically acts as a living style guide for the visual and functional user interface patterns that we use. So I'll show some slides kind of like that show you what Component Lab looks like. It's very bare minimal, very simple. On the side, there's sort of like high-level categories of components. We use a pattern called atomic design. So the sort of the smallest, most indivisible components are atoms. And then a molecule is like a combination of atomic components and so on and so forth until you have entire pages that are on the site that are 100% React components. And so in this slide here, we have our product detail page, so where we sell sunglasses. And what's nice about this is that this has been prototyped entirely in Component Lab with no knowledge of anything but some mock API data. And within Component Lab, you can actually use tools to view it at different widths. So here we have tablet size, and then here we have full screen. And so what was nice about this sort of engineering pattern is that our front-end developers could get into Component Lab, figure out what components already exist, build things, prototype them, we can QA them, we can test them in different browsers, all within here before any of this stuff ends up shipping to our live site. So what are some of the things that we learned? So actually React, it's very seductive with React because you can build these like amazing stateful components that do a lot of fancy stuff. But you can also just build really simple components that just render plain markup and a little bit of CSS. A good example of this on our website is that our navigation, which has a lot of state because you can open it up and close it, doesn't maintain any of that state within React. It actually maintains that state in hidden radio buttons, very like 90s era like HTML. And what's nice about that is that you don't depend a lot on JavaScript when you're delivering this markup that's rendered by React on the server. Some of the other things that we ran into were that mobile devices can struggle with really large DOMs. Our gallery page, which has lots of glasses, lots of images, does have a hard time on older devices, but there are ways to make optimizations. And if you're ever going all in on React, see the talk later today at 2:50 about Redux, and definitely use immutable objects. That's something that I regret that we didn't do with our stack. But so how did we end up doing performance-wise?
Yeah, so how did we take all Michael's change and operationalize it? The first and most important thing is to pick a mascot. So this is ours. It's Sonic Man. We think he smokes and drinks cheap whiskey and gets winded quickly when he's doing his spins. But seriously, so we have this interesting, fun process at Warby Parker. It's called Architecture Review Board. And anytime you want to make a big change to your stack, you basically do a quick write-up, and you can just kind of ad hoc call it any time. And any engineers or other people can come in and comment. And I'll tell you that the reaction to introducing Node into our stack, being a Python shop, it probably wasn't the most positive of reactions around. It was a pretty, there was a lot of debate, let me tell you, in this ARB. Me personally, I do in fact like Node, but I was really worried about putting something in the middle right in our core rendering path right there. It's, I've done performance for a long time, and it's like you never ever want to put more hops in. You never want to put more processing. I saw that, I'm like, yeah, that's plus 200 millis right there. That's not going to help very much. That was sort of my first initial negative reaction to this idea. And not only do we have to worry about performance, but it's a whole new layer. You got to worry about keeping it up and monitoring it and performance monitoring and all that fun operational stuff. So it's my sarcastic thanks, Michael, for all the new fun work for us. But Michael and I ultimately we kind of sat down and just went through the math. And especially in the mobile world, rendering time is such a problem, especially if you're on Android devices. And rendering server side, when we stared at the math, we're like, this actually feels right. It feels like it'll actually help things. But in order to make sure this project was successful and to make sure we really did help things, we wanted to make sure that we had a good process and a bunch of tools in place to make sure we did improve things and we did go really, really fast. So we did, a basic continuous improvement framework. We picked some goals and metrics. We make sure we stare at lots of data at some cadence. Right now, that feels like it's almost daily, that cadence. Earlier in the project, it was probably every 2 weeks. And then we pick tasks and just try to drive all our metrics down. It's pretty simple an idea. It's just harder than it seems to implement. So a couple of key notes about that. One is what are our metrics? So we care a lot about 3 metrics. One is render start time. When do users first start seeing stuff bubbling up onto the page? That's one key metric for us. The next is time to interactive. When does the page actually, when can a user start clicking stuff and seeing images and doing whatever they need to do with it? And last but not least is page load. We keep an eye on page load. It's not the most important metric for us because we got all kinds of third-party async tags, Facebook advertising stuff and so on and so forth. So we keep an eye on it, but not the most important for us. The 2 big difficulties in implementing this, the first one is people, and you just really need people who understand. It can be hard. We were fortunate. We've got this guy Frank. He's the one who came up with the Sonic mascot. He, has a lot of expertise in this area. He stares a lot at flame charts and graphs, and I look at them with him, and so on and so forth. So that's one, thing you have to make sure you have if you're going to go about such an ambitious project as this. And then the other is you need a heck of a lot of tooling to get the data to really understand how you're doing. Not surprisingly, new Relic is really sort of the cornerstone for us in this whole entire adventure. This view is actually something fun and current for us right now. This is our gallery page for women, and this is the node layer itself. So you remember I was like, oh my God, we're going to have 200 millis. What was worse, we added a second. It's 1,000 millis. And so we look at this page and we're like, oh, what did we do? And it's kind of fun, we see our Redis, it looks fast. We see our APIs, it looks fast. But then something's happening up here in the node layer. What is going on there? And we think, Michael and I will go spend some time on this when we get back. We think it's just actually, Node is single-threaded, non-blocking. But when you start to compile and so on, it can block up. It can block, and compiling, React isn't necessarily the fastest operation around. It can be pretty heavy on the server side. This is a good example of how we sort of dove deep on some data and tried to figure out some hairy issues. We also have this sort of fun is it working dashboard. We, like I'm sure lots of you, have TVs all over the place. This one sits right beside Michael's head by his desk, over with the front-end devs. And this is a really quick operational dashboard we use to see at a glance if everything is working correctly, is our rendering working right, is our cache working right, and so on and so forth. Really useful, when we do deploys to see if something changes and if we broke something. We do a lot of synthetic and simulated traffic. There's two real reasons why we do synthetic. One is it's great for before and afters and also great to compare controlled tests. We do a lot of controlled tests using Optimizely, and it allows us to put them side by side and take away all the noise of real user monitoring where you've got the network in the way. You never know what the network is of the end user. The synthetic traffic allows you to pick your network speed and see what you're actually raw performing at side by side. And last but not least, we do real user monitoring. This is obviously the most important thing for us to communicate to the rest of the organization. It's, what are we really truly performing at? We also use this to troubleshoot, specific geography or browser style problems. We can see Chrome mobile isn't working particularly hot. Why is that? Because Android kind of sucks at JavaScript, and so we get to use it and come to and do some fun analysis like that. So we take all this fun data and we tie it all together. We've got this great monthly report we send out. We take this data, we build a fun, compelling story. This guy Frank, he sends out this email and it tells us how we're doing, what's up, what's down, what's going faster, where are we going, and so on and so forth. So that's sort of the architecture and how we operationalize it. So the big question is, how did we do? You guys ready? So I'll tell you quickly. Sorry, it's a little hard to make sense of here for 1 second. On this side here, you can see the charts. They've been down. That's good news. Some pages got seconds faster. Some pages got hundreds of millis faster. That data is kind of interesting. The way we really tell our story internally is we use a heck of a lot of video. There's one big problem when you use video, and it's literally that it's a sample size of 1, so it's not always the most statistically relevant. But man, it really helps people understand how you're doing. So we use a lot of video. This is generated on web page tests. Not only do we use video, but we like to rank ourselves against competitors, other industry leaders, our friends, and see how we're doing. So for those of you who don't know, Zappos and Amazon are basically considered the 2 best for e-commerce, the 2 best and most performant sites. And you'll see here at 2.6 seconds, Warby fully rendered. Amazon half rendered. Zappos, they only got title. Woo, victory. And last but not least, not to lose business impact, conversion is a funny beast for us because people often don't just, you don't necessarily buy prescription glasses just straight off the site. Lots of people do, but lots of people like to do home try-ons. So we were able to boost home try-ons by 6%, which is phenomenal at our size. So it really was a big win for the business. It got everybody really excited. The board was talking about performance. It's been a big win overall. So go fast.
I think we have some time for questions. Yeah, if anyone has any questions.
We got any questions?
Just come up to a microphone.
Sonic.
Hey, I have 2 questions. One, you mentioned coupling CSS and components.
Yeah.
How did you guys do that? What solution do you use?
So we didn't end up using a solution. If I were to start this project today, I would absolutely do that. And I actually forgot to mention that in that slide. But we use a really nice pattern that's very sensible, where all of our classes are namespaced with the components, but we do just use normal CSS. I know there's some people out there who advocate using inline styles with React. I would be pretty open to that. I really feel like once you have reusable components, it just makes sense to kind of encapsulate all that stuff together instead of having to chase it down in a lot of different places.
Mm-hmm. And my second question was, how do you guys communicate between Python and Node? Do you guys use a protocol?
HTTP.
Yeah, nothing fancy there. Just
REST.
Old HTTP.
Yeah.
Cool. Thanks, guys.
Thanks.
Hi.
Hey.
I looked at the component lab and I thought that's a really cool piece of internal tooling.
Yeah.
In your talk, you mentioned using basic HTML elements for capturing state. So my question is all of your state represented in that way?
No, absolutely not. It's represented in places where it makes sense, right? You want to deliver the markup for the navigation. People might use that navigation right away. So we did it that way in the case of navigation, at least for that example. Mm-hmm. But there's certainly places where we're maintaining state in a lot of different ways, particularly for checkout and things like that. So it just depends. If you can push it down to just regular old HTML, I think there's a benefit because it's going to work in more places. But yeah, it's not necessarily a rule.
And my second part is, if you do keep state in some other system in the runtime, how does the component lab deal with that?
Well, in the case of the navigation, the state's only in the radio buttons that are hidden, and so it doesn't really matter. But yeah, I think does that make sense?
Well, if some components in the component lab don't use the state encapsulated in HTML, then you have to stub the state in the component lab's tool.
Yeah, no, we have, a very fluxy kind of architecture for that stuff. Yeah, I can talk to you about it afterwards.
Yeah, I'd like to.
At length, sure.
Last question, maybe?
Right. So I actually love Node, but in your case, why use Node in the middle when you can directly use your single page app to talk to the backend API?
Sure, and the app will work that way, but the reasons why we wanted to put Node in place is to be able to render and deliver usable markup immediately. That's that sort of graph you saw where our page was rendering right away because there wasn't anything for JavaScript to really do. Nothing to go prefetch, no API endpoints to prefetch. That's sort of the main reason behind that.
We actually tested both, and we were always faster on server side generally. It really depends on what your app looks like, though.
Yeah, there's no reason why you couldn't skip the Node part and just deliver an empty page that just fetches all the things it needs and renders itself. That's absolutely an approach for a lot of people that makes a lot of sense.
So you're basically saying that when the app loads up, there's no AJAX call back and forth. Like all the data is self-contained with that single request.
Yep.
Okay.
Unfortunately, we are out of time.
Cool.
So this was an amazing presentation. I'm sure there are tons of questions. Dan Morel, Michael Branch will be standing outside to answer all of your questions. But right now, we have Jason Chan coming up from Netflix to talk to us about security and compliance. So everyone, please put your hands together for Jason Chan.
Jimmy, appreciate it. Hey, everybody. It's funny, I'm following Warby Parker. I think this is my 5th pair of Warby Parkers. So I see really well. I still can't read JavaScript. So I'm Jason Chan. I'm a director of engineering at Netflix, and I'm responsible for security. And what I want to talk about today is, how do we get all of our, we have a bunch of apps that are and systems and data that have some kind of compliance sensitive, obligation, right? So how do we get those to the model of development where we can use things like microservices and NoSQL and cloud and agile DevOps, all that kind of fun stuff, and without having developers and auditors kind of ripping each other's hair out. So that's what we want to talk about. Just clicking again. Oh, there we go. Sorry, behind one. So when I think of 2015 for developers, it's kind of like a kid in a candy store, right? Where you have all these new languages, all these new frameworks, really optimized for getting ideas out of your brain and into production as soon as possible, as quickly as possible. And the same year, but for a different audience, right? Auditors and security teams, it's kind of like walking into a room with a bunch of mouse traps all over. Like every step is kind of fraught with peril. There's something going to go wrong. The pessimists in the room will probably say that's kind of every year for security people. That's how we always think. But really now with all this new change, it's an interesting time. And to me, kind of digging into the problem a little bit more, it's about the incentives and perspectives for each of those groups. Because as developers, which I know most of you are, you think about what you're asked to do. You're asked by product managers and by the company to create awesome products and great new features as quickly as possible because that's kind of how competition works, right? You need to move fast. And if you're asked to do that, the reasonable sort of response is, well, you want to have freedom to innovate. You want to use the technology that makes the most sense. And auditors, it's not that they're anti-business. I mean, they want the company to be successful. We understand you need to move fast. But there are systems that you do have regulatory obligations that need to be met. And when we map that to technology, how we typically think is we want to have well-known technology. We want it to have gone through audits before. We want predictability. We want stability, all that kind of things. And that's what sort of drives this tension, right? And to me, what resolves that tension, it's more of an operational change that's really embodied in this quote, which you've probably seen before from Werner Vogels, who's, of course, Amazon CTO. It was actually almost 10 years ago. It's you build it, you run it. So if you're building production software, you're going to be responsible for running it. So that's kind of the core of DevOps, right? So there's no more throwing stuff over the wall and letting somebody else handle it. And when you're a developer and you have to operate your system as well, it really drives vastly different behaviors in the design, what kind of monitoring you have, what kind of tooling, how you interface with that system. And the interesting thing that has been kind of an interesting discovery for me is that the change in that mindset for developers is exactly what auditors want. It's how auditors think. And to maybe make a little more sense out of that, take a look at these questions and sort of think, who's asking those? So if you get the proverbial call at 2 a.m. and something's broken on Netflix, right, and you're on call, you want to know the answers to these things because it really speaks directly to your ability to be able to support the system. And auditors, they're not supporting the system, but they need to verify the system. So not to completely like oversimplify an entire industry, but technology auditors are really, it's about verification. So does this system produce accurate financial reports? Does it protect credit cards? Those are the kind of things that an auditor needs to verify. Same questions. So now where we want to get leverage from is you have two different audiences that are asking the same questions. So that's kind of how we want to operate. And we want to go kind of from this model where we might have thought kind of tug of war to more of like the sort of best friends approach, right? This is the goal. We want developers and auditors to be happy, to be hugging and kind of frolicking together. But obviously you don't wave a wand. There's some work to make that happen. And in terms of how we get there, I've worked in security pretty much my whole career, and most of that career is also somewhat involved in compliance here or there. And there's kind of two approaches to compliance. And one of them is what I call a checklist approach, where you basically say, well, what am I responsible for? And then let me just one line item for each thing. The problem is, well, there's a few problems. If you're any kind of complexity, you probably have multiple regulations to adhere to. So then you just expand it. You have duplication of effort. Sometimes things change. And there's also, to me, which is important in terms of somebody who kind of runs a team, is that there's a human element there where people don't get really jazzed up about going to work saying, hey, I'm going to check some compliance boxes today. That doesn't get people excited. And then the other approach to that, what I'll call like a pillar-based approach, is where you're saying, hey, look, regardless of any particular regulatory requirement, I'm just going to design things around these sort of core operational principles, these core design principles. And then that's how I'm going to build my system. That's how I'm going to build tools and interfaces. And as a result of that, I'm going to be able to meet compliance requirements. And we'll look at some examples of that. So the way I call it, and this looks like a little bit of a kind of a marketing phrase, but the adjectives I think are accurate because it's effective in that it will allow you to meet requirements. It's efficient in that it's going to save you money and save you resources. And it's flexible in that it allows you to meet multiple requirements. So it's not just one thing. And so the pillars that we'll talk about today, 3 of them. One is traceability and development. The second one is continuous security visibility. And then the third is compartmentalization. So we'll do a little bit of a deep dive in each one of these things and see some examples. And then the general format, what we'll do is sort of explain what I mean by each pillar. I want to take a look at some examples of stuff that we've done at Netflix to kind of embody that pillar in our operations and tools, and then show how that maps to regulatory compliance. So you don't need to know anything about regulatory compliance, but we'll sort of close that loop just to show how it all works. So diving into the first one, which I'll call traceability and development, if you're on a big team or you have a lot of developers, you have a big system, distributed system like Netflix, these kinds of questions are really important to be able to, or these kinds of items are really important to be able to do. And the same thing that auditors want. Like auditors want you to test your changes. They want you to review your changes. But really developers, generally if you're responsible for your system, you're going to want to do these things anyways, right? So the way that we kind of make this pillar come to life is a system that we built called Spinnaker. And Spinnaker is a system we're actually, kind of good timing, we're actually going to open source it next week. So keep an eye on our tech blog for that. And basically what Spinnaker is, it's a system for continuous deployment. And what it allows you to do is it has this concept of pipelines or workflows. And you as a developer or a development team, you compose your workflow however you want, based on whatever your requirements are. You want to insert tests here. You want to insert restrictions here in terms of what region you might deploy to. Oops, went backwards there. Gives you a single interface to your entire deployment process. And then it answers all those questions, the who, what, when, why, for developers and auditors. Just one place to go to serve multiple audiences. That's really what we want to do in terms of leverage. So this is just a little bit of an overview of some of the stuff that we'll look at. We'll talk about integration to development. We'll talk about push authorization, restrictions around deployments, and then deployment notifications. So this is a view of Spinnaker. And so we run in AWS, Amazon Web Services. If you're familiar with AWS, it doesn't really have the idea of an application. It's kind of, an application in AWS is kind of an aggregation of a bunch of like cloud primitives, things like load balancers and security groups and IAM users and a bunch of other stuff that you need to kind of cobble together to run your app. So what Spinnaker does is it takes an app-centric view and it gives you a view of all that. So this app here is called Play Ready and it has all your interface to all your bits there. And then each one of those horizontals is what we call a pipeline. And what Spinnaker also does is allows you to link right into your build system. So we happen to use Jenkins, get to all your build artifacts, all your build results. It gets to, we use Stash, or I think it's called Bitbucket now for source code management. Get a link into all the code that changed, that triggered this build, all the pull requests, all that stuff available in one place. And then the core of Spinnaker, as I mentioned, is this idea of a pipeline. And that's what these horizontal lines are. Each one of those blocks is a step in the pipeline. And you as a developer create pipeline with 1 step, with 15 steps. It doesn't matter. It's meant to be tailored to your requirements. You see we have multiple deployment stages. Some of them are automated, and then some of them are manual. And you've probably never seen Spinnaker before, but you can probably associate the green and the red. Green, good, red, bad. So red, this particular one means that a test failed. So we had some kind of test in our pipeline. It failed, so don't proceed. So let's dive into that test. And that test, what happened to fail was what we call automated canary analysis. And you may be familiar with canary testing, kind of like A/B testing for your code, where you'll take the new version, send it into production alongside the old version, take some traffic, run some tests, run some metrics, and then decide if you want to promote it. And with automated canary analysis, that's totally hands off. So if it passes your test, go ahead and promote to production. There's no reason to have somebody involved. So this is the exposure in Spinnaker to that entire interface. You'll see here the canary test score. So we actually did a canary test in 3 regions, in Europe and West Coast and East Coast. 1 of them it passed, 2 of them it failed. It gives you links right to your test results. So you don't need to go digging to see what went wrong. And then it just gives you the results there. So you have this integrated testing. We saw earlier how we had integration to our CI system. Next is the idea of a manual approval. So even if you went through the automated canary analysis and everything passed, it looks great, it scored 100, sometimes you just need to have somebody give a thumbs up. And a lot of times with regulatory workflows, you need that. Somebody needs to say yes. So if I were the one to say, yes, let's push this, it would capture that information. Then that becomes an artifact so that people who are supporting the system understand that. They know they can blame me, and then auditors also know that, okay, well, Jason's the one who did this change. We also have the idea of a restricted deployment window, because over time, what we found is that it's not a great idea to deploy code right during the peak of your production time. So that's a good idea, it's a good practice, but why not just go ahead and make that part of your workflow? So that's what Spinnaker lets you do. And right here, basically what we're saying is only execute this pipeline between 4 p.m. and 10 p.m. So any other time, it's not allowed. You can also restrict by regions. So we've also found it's generally not good to deploy globally. So we'll deploy maybe to Europe first, and then East Coast, then West Coast, kind of a phased deployment. You can do it all automated. You can insert manual as needed. And then lastly, we'll see this idea of a deployment notification, so that every step of your pipeline, you can be notified by email or SMS. You can do like a chat ops integration, anything like that, just so you have full visibility. And then kind of, if you think generally about deploying code with Spinnaker versus manual deployments, what Spinnaker lets you do is deploy completely independent of languages. So you don't need to know, well, how do I get this jar file or war file or anything? It doesn't matter. Python, Linux, Windows, all gets deployed the exact same way. And you have you have multiple stages of automated testing that you have access to. So integration, security, canary testing. And then it's a fully traceable pipeline, right? So you can go from what's running in production and you see, well, who did that push? Who authorized that? You go back another step, you look at the build artifacts, you go back another step, you see the code that changed, you see the JIRAs that were filed to make those code changes. So it's all right there. It's a very nice tool for developers to be able to support and auditors to be able to verify. And then sort of mapping that to control. So this is kind of the auditor part of it. When PCI is around credit card security, SOX is around financial reporting. They both tell you that you need to test code before you deploy. And then PCI also requires you to do code reviews, and we saw how that's integrated there. So sort of how that works is you think of this principle, which is traceability and development. You think, hey, that's a good idea, we want that. So then you build tools around that, and then the outcome is that you're able to meet regulatory requirements. That's kind of the cycle that we follow. The next one, it's kind of related. It's the idea of continuous security visibility. And as a security team, especially in a large environment, things change all the time. And I need to know, do those changes have some kind of impact on the security posture? So what we do, if you think about it from an application portfolio perspective, you have a bunch of apps, and you need to decide which one of those are most critical and where should you be spending your time. The problem with how we do that now is we usually do spreadsheets, and we ask people to fill them out, and then we make some decision about the criticality. The problem there is that humans lie, kind of intentionally, unintentionally, they answer ambiguously. It supposes that you're actually going to capture everything, and you're going to be able to get a spreadsheet in front of somebody. And that's very it's sort of anti-innovation, because if somebody has an idea, their first thing, about a new app or a new feature, their first thought isn't, hey, let me go check with Jason to see how risky this might be. It's, let's test something out. And then it tends to be one time. So maybe you do it once, but as code changes over time, it gets out of date. So you ultimately have this system that's it's full of errors, it's non-comprehensive, and it's out of date. But that's really the best we have in terms of resource allocation. So we think we can do better than that. And kind of the nice thing about moving to this new model of development is that it makes it much easier. So I saw this tweet a few months back, and it really captures the kind of idea of microservices where, the microservices, the idea is to simplify, but once you get a big distributed system, you can't really keep it in your head. But that's what computers are for, right? So use computers to automate your awareness and your analysis. So that's what we did when we built a system that we call Penguin Shortbread. And kind of for lack of a better catchphrase, it's automated risk analysis for microservices architectures. And basically what it does, it doesn't involve humans. What it does is it looks to see how microservices actually talk to each other, and it observes different characteristics about the application. And then based on those observations, it sort of reasons over that data to get some kind of decision about how risky is this app. And then that's how we make decisions. So the core to Penguin Shortbread is an application risk metric. This particular one we call the dependent applications risk metric. And the idea is that if a bunch of systems depend on my system, then my system is sensitive. It's not a perfect metric, but it's kind of a proxy. And the idea is that if you make lots of these metrics, and maybe each one of them is imperfect, but more observations give you a better view of it. So that's what we try to do. And this metric's pretty simple. You see the algorithm there, it's just a little bit of Ruby code there to sort of calculate how many dependencies are calling this one. And then what we do scoring-wise, basically, hey, if between 50 and 100 systems depend on this server, I'm going to call it high, I'm going to have it high risk in terms of dependency. And then what you do is you make as many observations as you can that you think will give you some kind of insight into the risk or the security posture of it. And then you calculate that. So this is an app called Cryptex. These are all the metrics that we would run. And these are the scores across regions and across test and across production. And the idea is that as a security team, you would say, well, let me look at my riskiest apps, and that's where I want to focus my attention. So it gives you some kind of knowledge, and you're not relying on human input, and it's always up to date and comprehensive. Then mapping that to things like PCI and SOX, PCI tells us restrict traffic, and that's what Penguin Shortbread helps us do because it knows exactly what needs to communicate. And both PCI and SOX actually tell you that you have to have basically a risk assessment process, and that's what Penguin Shortbread helps us do as well in an automated way. And the last sort of principle or pillar I want to talk about is compartmentalization. And this is very key when you think about distributed systems in really two dimensions. The first one is resilience. So a lot of times you'll hear the phrase limiting blast radius, and you'll hear about like bulkheads where you're trying to, these kind of inner walls in a boat that prevent the boat from sinking. It prevents too much water from getting in. You're limiting how bad something can get. And then there's also the dimension, which is more security-centric, around confidentiality, right? So if I have a secret and I want to keep it secret, don't tell people, right? It's about need to know. If people don't need to know something, then don't tell them. And then we want to use this to our advantage, and it'll help developers and auditors. And the example I want to use is kind of integrates, you'll hear about the monolith to microservices migration. You'll hear about kind of data center to cloud. And so I want to talk about how we moved our payment systems, basically credit card processing, to the cloud. So we used to have, the data center, pretty typical. You have a payments application. You have people signing up through a website, right? Giving you your credit card. From there, what we would do is we would call an HSM or a hardware security module to encrypt that data. And then you store that in the credit card database. And then you have some kind of, obviously this is simplified, but you have a record like that, right? John Doe and then their encrypted credit card. And then the payments app, it calls out real-time and batch processing, and it talks to a bunch of systems like tax systems and fraud systems and analytics. And the problem with, well, I wouldn't say a problem, but the argument against a monolith from the developer's perspective is that it's a lot of functionality tied together, and it's hard to kind of iterate and sort of innovate without knowing you're going to break something. Everybody has to kind of be aligned, and it's difficult to kind of move at different speeds. The problem with monoliths from a security perspective is that every piece of functionality is something that could go wrong. It's something that can fail and have a security problem. And when I look at this kind of architecture, you have very sensitive systems that have a lot of inputs and outputs. And we call that, in security, we call that attack surface. So things with a lot of attack surface, it's not that they can't be secured, it's more difficult to do it. And it's more difficult to verify that things are actually working as you want them to do. So let's take a look at this model, and then as we transitioned it to the cloud and kind of went more microservices, sort of exploded this model. So you still, at the core of it is your payments application. You still have people signing up, hopefully, and through a web server giving you a credit card. And this is kind of where things change, because this is where you implement what's known in the industry as a token vault. And a token service does what's called tokenization, which is really, I mean, it's just taking a non-sensitive value and substituting that for something sensitive. So if you have something like a social security number or a credit card number, don't pass that around to everything, right? Keep it in one place, then have a label, a token that maps to that, and then pass that around. That's the safe way to do it. And then you store that sensitive data in your token vault. So now what we do is we call the token vault. The token service calls a bunch of crypto infrastructure and basically then stores within the token vault a mapping that looks more like this, which is a token to an encrypted card. So now you don't have that personal information there. You don't have John Doe's name there, so you've decoupled that. And then the payment app kind of does its thing, and in the payments database, you store the mapping of the user to the token. So what you do here is you reduce the attack surface and you make it much more traceable in terms of what's going on. And then you're basically, it's not that you don't have sensitive information here, you still do, but the idea of segmentation allows you to implement much finer grained access control, because here the token service, the only thing that's allowed to talk to the token service is the payment app. The only thing that's allowed to talk to the crypto proxy is the token service. So it's very easy to tell what's going on versus that monolith where everything is kind of scrambled together. And then mapping that to the controls, it's kind of funny because PCI, people complain about it all the time. It's the regulation around credit card processing. PCI has had this requirement for a long time of only one function per server. So I kind of say PCI has been recommending microservices for a long time because it simplifies things and it makes it easier to secure. And then both SOX and PCI require you to basically manage security, and that's what segmentation and compartmentalization helps you do. So just kind of wrapping up in terms of takeaways or recommendations, I really tried to get folks to limit investments that really just solve a very narrowed regulatory need. So anytime you think you're investing because, hey, we need to meet this particular requirement, that's kind of like an anti-pattern or a bad discussion to be having. You want to be thinking about how can you get more to the idea of designing around core principles. And then, because I think when you do that, you can then focus on tools and these techniques and processes that really benefit everybody. It's not just, hey, we do this just for auditors or we do this just for security. You're just doing the right thing and then everybody benefits. And then hopefully that's kind of the key to actually getting there. I think we have maybe a couple minutes for questions, but thank you for coming in.